So today we're going to look at the last section in Unit 6, which is 6-7. So you might want to put 6-7 up there. It deals with work and motion problems. So this is a more difficult section for you only because every problem is unique. So try to look at the problems that we're doing today and compare them to your homework problems. So in other words, when you come to a homework problem, look at that problem and try to determine, is this like a problem that I've done before? Most of them are pretty much done the same. It's just how you set up your equation. So for work problems, we want to figure out, for instance, you're going to have a number of people working one particular job. The more people that you work at a particular job, the quicker the job gets done. The fewer people that are working at that job, the longer it takes. So oftentimes businesses want to use work rate equations and formulas to try to figure out who to put together, how many people to put on a job, that type of thing. So to figure out a particular person's work rate or a particular machine's work rate, you are always going to use 1 over T, meaning 1 is an entire job, and T is how much of the job, or 1 is 1 hour, and T is the amount of the job that the person can do in 1 hour. So if you can do one whole job in 5 hours, then you can do 1/5 of the job in 1 hour. So for instance, Sean can mow a lawn in 4 hours, Tony can mow the same lawn in 5 hours. So Sean's work rate is, for per hour, would be 1/4. In other words, if it takes him 4 hours to do a job, he can complete in 1 hour only 1/4 of the job. And then Tony mows in 5 hours, so he can complete in 1 hour 1/5 of the job. And that typically will equal 1 whole job over here, not 1 over T. And then for our motion problems, we're going to be using various forms of the rate times time equals distance. So if I'm trying to find distance, I'm going to multiply rate times time. If I'm finding time, I'll take distance divided by rate. And if I'm finding rate, I'll take distance and divide it by time. All of these should be set up using charts. I expect to see your work as charts. Your chart is your let statement. So we're going to use the 4-step plan. And because your notes are already pre-done for you, you're not going to see me drawing that the 4 boxes. So just know that we're still hitting all 4 steps. So step 1 is your let statement. So this statement right here tells us what our variables are going to equal. And then it also is going to help us set up our equation to solve. So from this chart, we're going to get our equation to solve, which typically comes from here, not always, but from this column. And then we're going to solve the equation, and then we're going to answer the question in a complete sentence. So here we go. Let's look at number 1. So for number 1, I suggest that you highlight things that are important. So you're going to complete the table and chart below and write an equation. Chad can load a truck in 24 minutes. So that's important. So that means that Chad's work rate is going to be 1 over 24. And the unit of measure in time here is going to be minutes. And then we have James, which can work, it takes James 40 minutes to load the truck. So that means that his work rate is 1 over 40. So far we don't have an unknown. How long would it take them to do the project together? So this is the rate that Chad works alone per hour, and this is the rate that James works alone per hour. We don't know how many hours they're going to work together, but we do know that in this particular case, they're both working the same amount of hours. Sometimes they won't. Sometimes one person will start the job, and another person will jump in so many minutes or hours later and help them finish it. So you do have to pay attention to your time. So in this particular case, our time, well, I'm going to let our time be X because I like X rather than T, but that's just me. And then notice up here that this is telling you how we're going to calculate our 3rd column. So we got work rate here, time here. You have to title all of this up here. And then to get the work done column, you typically have to calculate this column yourself. So we're going to take rate times time and get the work done. So for Chad, he's got X over 24. And for James, he's x over 40. Then to get our equation to solve, typically we're going to use this. This is the amount of work done by Chad. This is the amount of work done by James. Together, if I add them, together, they will equal one whole job. So my equation to solve is going to be x over 24 plus x over 40 equals one whole job. So then you're going to use your skills that we've learned in this rational function unit to get rid of your denominators. So you could find your least common denominator, but I'm assuming you're using your calculator here. So you could find the least common denominator, but I'm just going to take 24 and multiply it by 40 just because it really saves me time. And I'm not going to be worrying about finding an LCD because I'm just solving. So I'm going to multiply all three parts, this, and this, by 960. So I know that 24 is going to go in here 40 times. And so I get 40x plus, and then I know that when I multiply 960 here, the 40 is going to go in here 24 times. So I'm going to get 24x equals 960. So add your 40 and your 24 together, and then I'm going to continue my work here. So if I add my 40 and 24 together, I get 64x equals 960. Divide 960 by 64, and we get 15. So this is what's beautiful about your table of values. What is x by this time? We forgot. Oh, x is the time it took them to complete one whole job together. So that was 15 minutes. You want to know your units of measure, so that was in minutes. And then we have to answer the question. How long would it take them to do the job together? So that answers the question, and so I'm going to write the answer. Therefore, it would take both Chad and James 15 minutes to complete the job together. Now, I'm going to be picky when I look at your work for this. I expect to see a full written sentence. You can use the therefore ... but then you have to use all the rest of your punctuation. Make sure you finish in a period. And then there's no equal signs in a sentence. There's no math symbols in a sentence. You can use units of measure abbreviations, that's fine. And you can use number abbreviations, but I don't want to see any other kind of abbreviation. This is a written English sentence. And if you don't do the 4-step plan when you do your homework, you are going to lose a lot of points. So please make sure you're focusing and paying attention and doing that 4-step plan. All right, so let's look at example 2. All right, so for example 2, let's read our problem. Morgan takes 6 minutes to weld a frame. So here we go. Here's Morgan. And that gives us her work rate. So that would be 1 over 6. And then we've got, with the help of Alec, the job can be done in 4 minutes. So we don't know how long it takes Alec to work alone. We just know that the job can be done in 4 minutes. So I know that together, if they work for 4 minutes, they can complete one whole job. So I'm going to put one whole job here. But I don't know Alec's work rate, so I'm going to put 1 over x, because that right there is my unknown. Remember, this is the column that we calculate ourselves, and we're trying to find out how long it would take Alec to do the welding job alone. So we've got to multiply these two together. So 1/6 times 4 is 4/6. And 4/6 reduced is 2/3. That's a 2/3. And then 4 times 1 over x is 4 over x. And so now we write our equation to solve. And we get that from this column right here. So we've got 2/3 plus 4 over x equals 1 job. Then our least common denominator is 3x, so I'm going to multiply everything by 3x, both sides. All right, so when I multiply these two, the 3's are going to cancel, so I end up with 2x plus, and when I multiply these two, the x's are going to cancel, so I end up with 12 equals, and don't forget to multiply the 1 by your 3x. So I want to combine the x's together, so I'm going to subtract 2x from both sides, and so I get 12 is equal to x. So x is Alex's amount of time that he can complete one whole job on his own. And the question says, how long would it take Alec to do the welding job alone? So that does answer a question. It doesn't always, so you have to really pay attention to what your question's asking. So therefore, Alec can complete the welding job alone in 12 minutes. So he's a much slower worker. Maybe he's a newbie. All right, so let's go to example 3. This time we have a motion problem. So motion problems means you're going in a particular direction at a particular rate, where work problems are you're completing a job at a particular rate. So they both have rates, but one's going in a direction and one is completing a job. So notice here that always on our tables here at the top, you should have, and I don't agree with theirs here, so we're going to cross these out. We're going to put rate, then put a times, time, equals, and then over here put distance. I don't like the way she labels the tops of her charts. Always put rate times time equals distance. We will figure out which of those 3 equations we need to use once we look at our table. All right, so let's read and fill in places. So train A has a speed of 14 miles per hour faster than train B. And oftentimes a picture here will help you figure out whether the distances of both trains are the same or are they different. Are they going in the same direction, different directions, that kind of thing. And then train A travels 400 miles in the same time it takes train B to travel 330 miles. So find the speed of each train. So we really don't know the directions of the trains are going. They could be in 2 different cities for all we know. So I'm probably not going to draw a picture for this one. So train A has a speed of 14 miles an hour faster than the speed of train B. So right there is some information for us. We know something about one of the 2 trains. So I want you to ask yourself, which one are they describing and which one do we know nothing about? So since they are describing train A has a speed of 14 miles per hour faster than the speed of train B, they're describing train A. So we know something about train A. We know nothing about train B. So I don't know anything about the rate of train B, so I'm going to let train B's rate be x. In terms of train B, or for train A, it has a speed 14 miles an hour faster than B, so we're going to write something faster than x, that's 14. So x plus 14. All right, then it goes on to say that train A travels 400 miles in the same time it takes train B to travel 330 miles. So we're going to skip the time for a minute and put in the miles. So train A travels 400 miles and train B travels 330. So to not, I mean, you could have 2 unknowns. I mean, technically and theoretically, we don't know the time, but we know that the times are going to be the same. So, I mean, you could set up 2 equations with 2 unknowns, but you could also determine what the time is for train A in terms of x and what the time is for train B in terms of x and set them equal to each other because we know they're equal. So in other words, one of our formulas, if I'm trying to find what time equals, don't we take distance and divide it by rate? So instead of y here, I know that y is equal to 400 over x plus 14. So train A would be 400 over x plus 14. So this is my train A. And then that should be exactly equal to train B's time, which is 330 divided by x. And so this is my train B. Now that we have a proportion, we could just cross multiply and solve, and it becomes very simple here on out. So let's go ahead and do that. So I'm going to multiply these together. So I'm going to multiply the 330 to both terms, so I get 330 x plus, and then 330 times 14 is 4620 equals, and then I'm going to multiply these two together, and so I get 400x. So I want my x's together, so I'm going to subtract 330x from both sides. So that gives me 4620 equals 70x. There's an equals there. And then I'm going to take and move everything over here. So then I'm going to divide both sides by 70. And that gives me a value for x, which is equal to 66. So we go back to what is x? X is a rate, and rate is in miles per hour. So I know that my unit of measure is miles per hour. And the question says, find the speed of each train. So this just gives me the speed of train B, but I have to also find the speed of train A. So A is x plus 14. So if we add 14 to 66, we get 80 miles per hour. Now you're going to see on the answer key, maybe, I can't remember how I did the answer key, but you might not see, you might only see the answer, and you might not even see a written sentence answer. It doesn't matter what's written on the answer key. I have to see all the work that you're seeing here in order for you to get full credit. So keep that in mind. So therefore, train A my dogs are trying to bark at the landscapers. So train A travels at 80 miles per hour while train B travels at, see if I can move this up. Oh, perfect. At 66 miles per hour. And that's it. All right, let's look at example 4. So example 4, it happens to be a work problem, and you're not always going to be told what type of problem it is. So you have to identify which type of problem you have, and that will determine how you label the top of your charts here. So 2 pipes carry water to the same holding tank. So we have this holding tank here, like a water tower, where 2 pipes are filling the tank at the same time. Okay, so pipe A can fill the tank 3 times as fast as pipe B. We don't know how fast either one of them fill the tank, but they've described one of them to you, and one of them we know nothing about. So this is important, so I would highlight it. The one that we know nothing about is pipe B. Now the problem when you have pipe A can fill the tank 3 times as fast as pipe B, normally you would be thinking, okay, I'm going to put, it's a work rate, so I'm going to put 1 over X here. But let's think about it. I'm just going to put some numbers to this, and then I'm going to erase them. What if pipe B, so let's just say pipe A can fill the tank 3 times as fast as pipe B. So remember that that means that pipe A can complete the work quicker. So maybe pipe A can complete the work in 1 minute, and pipe B would be 3 minutes. That's the way that would be read, right? If pipe A is 3 times as fast as pipe B, then pipe A can get the work done in 1 minute, let's say, and pipe B could get the work done in 3 minutes. So then pipe A's work rate would be 1 over 1, and pipe B would be 1 over 3, because it's a fraction. And remember, the bigger the denominator in the fraction, the smaller that fraction is. So since I know nothing about pipe B is going to be my 3x, and it's going to be 1 over 3x. And whoops, it's not going to let me erase it now. So we're just going to put pipe A as 1 over x, because I originally had 1 and 3, so I'm going to make it 1x and 3x. So that means that this is going to be a faster work rate than this one. So that's kind of the opposite of what you think it would be. So these ones are a little bit more difficult. So you might want to star this, because you really have to think through it. Because if you solved it the other way, you're going to find out that when you get to the end, that you're going to realize that pipe A actually took longer if you flip these around, and you'd have to rework your problem. So together they can fill the tank in 24 hours. Now that means that our work rate is going to be in hours. So we're going to put, we'll just put 24 in here. And you could do it in days, since 24 hours converts to a day. You could do it in days. But I'm going to leave it in hours, because I know that that means that X is going to be in hours here and here, which they both can complete it alone in more than a day. So we'll just leave it that way. Hours will be better than a portion of a day. All right, so then to get this last column here, you have to calculate it. So work rate times time, so this times this. So you get 24 over x. And then when you multiply 24 times 1 over 3x, that 3 is going to cancel into the 24 8 times. So I actually get 8 over x. All right, so then my equation, my second step, and remember this, if we add these together, it's going to equal 1 whole job. So my equation is going to be 24x plus 8 over x is going to equal 1 whole job. And because these are both x's here, I could multiply everything by x, and that's fine, but I could also add these two together and just cross multiply and make it a proportion. So that's what I'm going to choose to do this time. So 24 plus 8 is 32 x's, because remember, you don't add the denominators, you just add the numerators since they have the same denominator. And I'm going to make this equal to 1 over 1, and cross multiply, I get x equals 32. And the question was asking, find the time it takes each pipe to fill the tank alone. So that means that if x is 32, this is in hours, right? So that means that pipe A would be 1 over 32, but it really means that pipe A fills the tank alone in 32 hours. And pipe B would be 3 times 32, which would be 96 hours. So that's our solution. So therefore, pipe A can fill the tank alone in 32 hours, while pipe B would take 96 hours. So as you can see, if we had flipped it around, these would have been flipped around, and then pipe A would not have been faster. So think back through why we did these reversed, and it hopefully will make a little bit more sense if you ponder that a little bit. Okay, so let's go to example 5, and then we are almost done. So this time we have a motion problem because we have an airplane flying. So an airplane flies 1,062 miles with the wind. So that's going to be important. With the wind. We've talked about wind and current problems before. So we're going to focus on them again. So remember, when you're going with the wind is pushing at your back. So it's speeding you along. So it's making your rate faster. We still don't know the rate of the plane though. And then in the same amount of time, it can fly 738 miles against the wind. So when you're flying against the wind is blowing towards your face. So it's slowing you down. So it's taking your rate and reducing it. The speed of the plane in still air, so that is important. So the speed of the plane in still air is 200 miles per hour. Find the speed of the wind. So we don't know the rate of our plane in still air, so I'm going to let that be my x. Oh, and I don't like the way she's labeled this, so this should be rate times time equals distance. Okay, so with the wind, we know the airplane can fly 1,062 miles. So its distance is 1,062 miles. And then with the wind, it means that we don't know, we know the speed of the plane in still air is 200 miles an hour. So the plane's going 200 miles an hour, and with the wind means it's going to increase that speed. So I'm going to add x being our wind rate, to it. And then we don't know the time, so we'll skip that for a minute. And then it says that in the same amount of time, it can fly 738 miles against the wind. So you're going to take that 200 miles per hour and subtract the wind speed. All right, and so this is very similar to that other train problem where they both are going the same amount of time. So there's no calculating of this third column. Instead, we're going to write their times in terms of x. So recall again that if I'm trying to find time, time is equal to distance divided by rate. And so for with the wind, I'm going to let y equal 1062 divided by 200 plus x. I'll squeeze that in there. And then for against the wind, 738 divided by 200 minus x. So those should be equal because they're the same. So that's going to be my equation to solve. So 1062 over 200 plus x equals 738 over 200 minus x. So we have a proportion, so we are going to cross multiply and solve, and I'm assuming you're using your calculator. So here we go. 1062 times 200 is 212,400, and then minus 1062x equals, and then 738 times 200 is 147,600 plus 738x. All right, so then we are going to add 1062x to both sides. And that'll eliminate here. And at the same time, we are going to subtract 147,600 from both sides. And then on top of that, I'm going to flip my left and right side so my x terms are together. So the 1062 plus 738 is 1800. So I've got 1800x is equal to, and then 212,400 minus 147,600 is equal to 64,000 800, and then we're going to divide both sides by 1800, and we get 36. So by this time I've forgotten what x is. So go back and look at your table. Oh yeah, x is our wind speed, and they are asking us to find the speed of the wind. So our wind speed is in miles per hour. Okay, so therefore the speed of the wind is 36 miles per hour. And then our last problem today is number 6, and it happens to be another motion problem because we have a car traveling. So one car travels 25 miles per hour faster than another. So we don't know the actual speed of the car, but we know that one car is traveling faster. While one travels 300 miles, the other travels 450 miles. We don't actually know their directions, so again, a picture wouldn't do us any good here. Again, I don't like how she has set up her table. So this is going to be my rate times time equals distance. Okay, so one car travels 25 miles per hour faster than another. So you have to decide, and it doesn't matter which, you have to decide whether you are going to let this be the unknown car, and then you're going to define this in terms of this one, or vice versa. So I would probably prefer to let the slow car be x and the fast car be x plus 25, because then I don't have to deal with a negative. So I'm going to let the slow car be x, and then the rate of the fast car would be x plus 25. Then our time. So what do we know about their time? One travels 300 miles, the other travels 450 miles. We don't know anything about their time, but it's implied that they're going the same time. They just don't actually say it this time. So I'm going to go ahead and put y and y here. And then the fast car has to be traveling 450 miles because it's faster, so it's traveling a longer distance. And the slower car is traveling the 300 miles. Now, once again, we don't know rate, but we know that we don't know time, but we know that they're the same. So I'm going to take distance and divide it by rate and let that be my time. So this is going to equal 450 over x plus 25. And this is going to equal 300 over x. And so then we're just going to set those equal to each other. 450 over x plus 25 equals 300 over x. So cross multiply. We get 300. Actually, I don't want to do that. I want my 450 x on the left and 300x plus 300 times 25, I should have known that, 7,500. Okay, so I'm going to subtract 300 from both sides, so that gives me 150. X equals 7,500. Divide both sides by 150, and we get 50. So remember, x is in miles per hour. And the question says, find their speed. So x is 50, while x plus 25 is equal to 75 miles per hour. So therefore, the faster car is traveling at 75 miles per hour, while the slower car is traveling 50 miles per hour. And we're done. So make sure that when you do your problems, you're doing the 4-step plan, you're using charts for your let statements. Yes, I want you to use the charts. That I see you set up your equation, solve, I see you solve it, and that you answer that question with a complete sentence so that you get full points. Text me with questions.